thank you for joining us to this first data-centric AI webinar that we're organizing at the Open Data Institute. So this is a series where we have initially planned 6 episodes, but I can tell you already that there's probably going to be a bit more because there's lots of topics and lots of interesting people we would like to talk to and bring to you. But the idea was to set up a platform to invite world experts to tell us about their own research and experience, to share key insights and recommendations for building what we call the socio-technical data infrastructure that we need to make AI safer and trusted by everyone. We will also be taking the opportunity to share, where relevant, some of our own work in this context. So the speaker today is someone I very much value and respect. Lora and I have been working in a number of projects over the year. She's a research scientist at Google DeepMind in New York, where she works on a very, very relevant topic, and that is data excellence for AI. This work is part of the responsible AI theme at Google DeepMind, and the focus is on developing metrics, methodologies, approaches to measure the quality of data that is used in AI, whether that's labeled by people or generated by machines. And I assume Lora will also tell us about some of her recent focus on gathering and evaluation of data and adversarial settings to safety test generative AI systems. I mean, I could talk about your bio forever, but just to say you have a PhD in computing from the Twente University in the Netherlands. You've been at the Free University in Amsterdam around the time when we met, and you've been part and led many initiatives in this space between human computing and human computation, collective intelligence, and AI. And I'm really, really glad to launch this webinar series with you and your work. For those in the audience who don't know me, probably most of you, I'm Elena Simperl. I'm Lora's friend. I'm also Director of Research at the Open Data Institute. We're hosting this webinar, and for my sins, an academic at King's College in London. And now, Lora, over to you. And if everything is going to work well, you'll be able to share your slides, and it's going to be magic.
Let's see, did magic happen?
Magic happened, yeah.
Amazing. Well, if everything was so easy.
Indeed. So take away.
Thank you
We
very
thought
much,
about 20 minutes, but if you need a bit longer, by all means.
Thank you very much. And it's an honor to actually be part of launching of this very nice initiative in a very important area. And I hope I'll be able to give you some insights from my experiences in this area as well. As I said, so Elena already introduced me. So I just want to shortly probably don't need to tell anyone how rapidly we are advancing right now. But it's kind of important to make it clear that this is a very exciting area, exciting time to be part of AI. And I myself am really excited. I have never been so motivated to go to work every day. And I am really proud of the progress, the amazing progress that we've made in such a short history. It's basically making history. A big part of this progress has come from availability and really our focus on large quantities of data. But the pace of this advancement has left a trail of unintended behaviors, as we've already seen, and it keeps creating new ones, as we are seeing in the era of generative AI. So the recent rise of data-centric AI movement, which started somewhere beginning of 2020, end of 2020s, 2021 as well, brought in focus data quality in addition to data quantity. And you can check in the Data-centric AI Hub. It has a lot of resources, and also you can see the first workshop that we launched at NeurIPS in end of 2021, covering lots of the topics related in this area. All this gave rise to what we call responsible AI, or ways of deploying AI responsibly. And specific focus that I'm taking here is really studying various aspects of data that have impact on model behavior. And triggering, the why data is important, because this triggers sort of an emergent trend of critical activities, which we call red teaming, and these are efforts in order to assure safety and sort of responsible deployment of these models. And again, this also resulted in numerous new approaches to explore data and guide data, the AI for data through human feedback and alignment. A central aspect of such data explorations is really trying to understand how representative and how diverse this data is. And this is part of definition of the quality, data quality, for using in responsible AI. And specifically in this talk, I will present some empirical evidence from experiments with data gathered from volunteers and paid raters for the purposes of model evaluation. But I strongly believe that the results do generalize to various types of human-generated data, whether it is used for evaluation or training, such as web pages, news articles, books, user photos, YouTube videos, etc. So I will examine the quality of data by looking at the characteristics of the content, what's in the data, how those characteristics are distributed in it, and who are the humans that provided the annotation for this data, as well as the design of the data collection tasks. So let's begin. I'm going to kind of take you on a little tour through what I call my perspective on responsible AI, that starts with a simple observation about the data. So this kind of fast lane of AI has paved the road with a lot, kind of paved its road with a lot of binary distinctions, but encapsulated in the training and the evaluation data, but they very rarely reflect the actual reality. The history of our AI community came with all these traditions of binary distinctions like good and bad, expert or amateur, yes, no, true, false, black or white. And the vast majority of the data we deal with as data scientists does not really clearly fit into such narrow and brittle categories. In other words, the world is smooth, full of many spectra, where right and wrong, black or white are the endpoints of a spectrum, not the only possible values. And continuous functions are better and far more appropriate for the task at hand. And I will use some examples to illustrate why these binary distinctions do not fit our smooth world. For example, so these all examples I will be giving from various data collection tasks that I've done. Let's start with a very simple one, a question we asked to raters: is there a smile in this image? You can see for yourself, is there or is there not, but typically what the only two answers that are given to the rater is yes or no. So they can say unsure, but the only meaningful answers are yes or no. And here you can see what 19 raters from India, Canada, and US thought the answer to this question is for this image. If you look at the majority, then yes, there is a smile in this image. However, the number of yes votes is only one signal in this data. There is still quite a lot of no votes, as well as some amount of don't know votes. And if you look at the different locales, the US and Canadian raters can't really decide whether there is a smile or not in this image. What if we look at a little bit different example? So this is a question we ask for evaluation of generated images. So do you think this generated image is safe? Here is what 15 raters thought the answer to this question is. Again, the answer is yes if you only look at the majority. However, there is quite a lot of no votes, which indicate that there is a significant portion of these raters that consider the image unsafe. And again, another example for safety, what if we ask a question, do you think that so this is a conversation generated with the user and a chat bot. So what do you think the final bot response? Is it safe or not? And here again, we observe a similar situation. Most people think it's safe. However, the votes for unsafe and unsure together are equal to the safe majority votes. And in addition, the gold label provided by trust and safety experts says that bot response is unsafe because it contains stereotyping of a group of people. And as much as this is correct, are those 52 raters who think this is a safe image completely wrong? And what do we do about this? So these are the examples with which I was trying to illustrate why imposing an artificially binary distinction into real world examples is something that's very difficult to capture accurately. So our traditions of such binary distinctions are continuously guided by a set of assumptions, which I call myths. They attempt to force the real world into narrow and brittle categories, such as assuming a single truth exists for every example, ignoring the fact that examples are of different complexity and definitely not always equal, assuming rater disagreement is bad, and lengthy instructions are going to solve the problem of the disagreement, assuming experts always know best, to such an extent that even in many tasks, we would ask a single rater to give us the ultimate truth. So 10 years ago, a couple of hardly noticed papers were published on the idea that the disagreement among human raters can be productive, and summarizing it, meaning it's not a noise, but a signal. This was the crowd truth. That's how crowd truth was born. And in one of those papers, we analyzed the typical machine learning response to disagreement, which is experts. Here again, let's look at an example. This is a relation extraction task in a where medical experts annotate medical sentences to identify which of those sentences contain specific medical relations. Here, in this example, one of our experts decided that the first two sentences express the relation treats between the terms highlighted, and the third sentence doesn't. In addition, one of the things we noted is that experts also disagree. So especially of cases of ambiguity like this one. So this is just one expert. We have examples of other experts that actually gave for exactly those three examples different answers. But we decided also to try, what if we ask a bunch of raters? Will we get a stable distribution over time? And yes, we found that in every case we tried, eventually a yes-no rate stabilizes if you ask sufficient number of raters. And it stabilizes into something that in my intuition tells me that it's more informative than what we got from the one data point from the expert, and including the fact that we got different data points from different disagreeable data points from different experts. So if you look at the first two sentences, which the expert labeled both as positive examples for the relation treats, are now using the stable distribution from the raters, are now much more distinguishable. And I can see that the agreement is higher in the first one, and perhaps telling us that it's more clear than the second one. And for the last one, now I can see that it's not completely a negative example. So it sort of implied the relationship, but not completely. So using this kind of distributional truth or distribution of the answers rather than single point examples, we get more information from a crowd of 15 raters than from a single expert, even for medical examples, where most people consider crowd will not be as accurate as experts. And in addition, experts also, as I mentioned, experts also disagree, but they disagree in almost every domain we looked at, and with a pretty high percentage of disagreements. Some disagreements are resolvable, some are not, but in general, there is always a set of things that even after long discussions, raters are not able to, experts are not able to resolve. And most importantly, the ambiguity in those examples that we find a very prominent disagreement is not the exception. You can see, for example, here in our analysis of many domains and many rating tasks, we find disagreement to be quite common. So the larger spectrum of the data collected usually contains some form of disagreement, where the very agreeable aspects of the data are much smaller. So we began studying human annotated adversarial data that was presented to raters and focused even more on identifying the signals that come from this disagreement. And we observed that disagreement could come from a variety of sources. So it's not only important to know that there is disagreement, but once you're able to capture it, it's really important to understand what causes it and what are the different sources it can come from. So in our theory, based on the old idea of linguistic, known sometimes as the triangle of meaning, is that every semantic interpretation task has at least three parts: the raters, the content, and the task that they are performing. And they all play a role in understanding disagreement. And in our crowd truth research, we studied these sources: the disagreement caused by the rater annotation scheme, such as subjective, time-sensitive, or mistranslated annotations; disagreement caused by the diversity of the raters, individual raters with specific knowledge, communities of thought, or even spammers; and disagreement caused by the diversity of the examples, items with poor semantics, salient terms, or simply ambiguous. So let's have a look at some more examples. How many of you think that this image depicts a guitar? I don't know whether you can raise hands or anything, but just register it for yourself. How many of you think this image depicts a guitar? What about this one? So guitar is in the title of the last one, just for the ones who are wondering. So even for such an easy question, that sounds like, okay, images of guitar, it should be easy to answer. It is not easy to give us straightforward answers. And yes, I might have tried to find the very convincing examples, but it's actually not nearly as difficult. Just in a simple search for guitar, you're going to start discovering images or examples that you probably have never seen before, and you doubt yourself whether this is indeed a guitar or not. So poor data quality of your annotation experiment is usually not because of human error, but because of something that's intrinsically captured in the content of the content of the examples that you have presented. Similarly, what if we change from guitar, we change the label to New Zealand? Does it get easier? I don't think so, because will always be this ambiguity present in the data that could potentially be resolved with more context. If I just simply ask for New Zealand or images of New Zealand, it's really not clear what for. Is it New Zealand flag? Is it New Zealand sceneries? Is it New Zealand people? And so on. So all of this would be answer to the same question, but they will be different representations. But the context of use is not always enough in order to resolve ambiguity. Cultural differences in depicting and interpreting problems are very natural part of our real world tasks. So it is only natural that raters will persistently disagree on them depending on their own different either demographics or experiences. And our conclusion from all this is that disagreement is a signal for the natural diversity and variance in human annotation, and should be included in the training and evaluation data and not avoided as we typically do. The problem is that diversity is not easy to predict. It's easy said, but it's not easy done. So here another set of examples. In this task, we asked raters from different countries what food items are served at various restaurant types and in or outside of the country they live. We expected that raters from the same country as the restaurant we were asking for will have lower error rates than the raters from outside of the country. But it wasn't the case. For example, raters outside of the US were much better than raters in the US at predicting what food items were served at various restaurants in the US. The same was true for Brazil, India, and other countries, except Japan. So this was totally unexpected. So even though it's easy to start discovering some trends, you should always expect that when you deal with diversity, there will be some unexpected results, that not everything will fit in the schemes that you're defining. And we have done many experiments in different domains and different data items like tweets, news articles, video descriptions, medical text, and so on. And here we show across all of those tasks that crowd-truth method performs better than any of the evaluating data quality because of its disagreement-tolerant way. So we turned our attention to a new problem, one of incredibly high stakeholder importance, and one in which we fully expected disagreement to be a major factor. And we decided to turn up the heat a little bit by experimenting with actual rater diversity. So here I would like to introduce to you the safety with diversity, a method which we used in order to scrutinize data for safety by looking into what it is what was in the data and who annotated it. We produced a data set called DICES.
Just one second. Just to give you a heads up, so we're hoping to wrap this up at some point soon. So it's up to you.
Yeah, I can actually
you would
more or less stop here. I
okay.
can more or less stop here and just give some of the slides just as a summary. I'll introduce in 1 minute the data set. So this is more or less the data set description. So it actually contains 2 data sets with about a little over 1,000 conversations generated by a chatbot and user, specifically rated for safety. And the interesting thing to remember from this is that we used a very diverse rater pool across different demographic areas, specifically designed in order to have a good coverage across all the ratings. And we used a very exaggerated replication rate. So we had in 350 cases, we had more than 120 raters per example in order to rate this for safety. I already gave you this example. I just wanted to show you something which was kind of interesting to know. the little red part there is really showing that the amount of data that, which is actually, it doesn't look very much, but it's about 30% of the data, falls into cases where 120 raters were not able to resolve whether it's safe or unsafe. So even in this large amount of raters, it was not enough in order to get a very reliable majority vote. And I would like to summarize, just to give you the last two slides. So first of all, our data shows that collapsing this response distribution to polar opposites is a bad practice. And even though I skipped through many of the examples, I hope I managed to convince you that there is really a reason to consider the whole spectrum rather than the two endpoints. Rated disagreement is an important signal, and realizing the spectrum between those two polar opposites, such as safe and unsafe, black, white, good or bad, is really, really important. And furthermore, rater diversity is really an important aspect to study, and provides us additional signal to enhance our ability to find confounds and better model reality. So we need approaches to quality that actually capture rater, embrace rater diversity, capture it, and create confidence metrics that account for differences and disagreements between them. And I think once we actually accept the fact that diversity is really, so polarities don't really work, and work more as a harm amplification rather than understanding, it's really good to understand how we can align the performance of the models to these diverse perspectives and diverse viewpoints. So weaving diversity of perspectives into data is a complex problem, and it's really interesting and challenging one to study. And I hope you all this inspired you in one or another way to do so. Thank you.
Wonderful. Thank you very much. Thank you. I think it's very fitting that we're talking about diversity, because the audiences we have at the ODI, when we run this sort of events, are quite diverse as well. So I wonder, before we get into more specific questions, whether it's perhaps worth explaining in brief terms how that labeling process works, just in very just a very basic introduction, because I wonder also if people know, for instance, what the gold standard is, or the ground truth, or a rater. So would you mind perhaps summarizing just the basic process and the main terms?
Yeah, I probably can just bring one of the slides that I had with the image. So it's very simple. You have a collection of items, whether they're sentences, whether they're images, videos, articles, and you want to know something about them. You have some kind of goal. You want to know, are they safe? Or you want to know what is the main topic of the article, or are there people present in an image, and so on. So you define your question, so your goal, and you also define what kind of answers you want to get from people. Do you want to ask them, do you want to collect answers like yes, no, maybe? Do you want to give them a scale? Yes, there are many people, few people, no people at all. So these are all considerations that you need to, that are part of designing your task. So designing your question, designing your answer scale and answer shape, and understanding whether any other sort of feedback or input from the raters is needed in order for you to be able to process and meaningfully interpret the results. Mm-hmm. Typically, this is given to your collection, you let's say have 100 images and you want to be annotated by raters, you need to decide how many raters per item you would like to have. The more raters you get, the higher chances that you will have some stability and statistical significance, as you have seen, especially in cases with disagreement. And if you want to study diversity, you need to actually spend time to design your diverse pool. You need to be able to identify what kind of characteristics in raters you're interested, how much, what proportion of those characteristics need to be present in your rater pool, and what is the best source of raters in order to achieve this distribution of characteristics. And then you run your task, gather results, and analyze.
Thank you. This sounds all very easy.
Yes.
Those of you who have seen Silicon Valley, which is one of my favorite shows, there is an episode there called Hot Dog, No Hot Dog, where someone wants to train an AI, which was of the sort of the predictive kind. So you want to train an AI system to tell you what we call in computing object recognition. So you have a bunch of images, you have 100 images like Lora was talking about, and the AI should say what's in this image. And of course, the more options you have, the harder it's going to get. But in sort of classical AI, the way to do this would be to have examples. So you would need these raters, you'd need these people to look at these images and say, okay, cat, dog, cat, dog, something else. And the trick there basically is to try to automatically understand which answer is correct, because you don't want, as an expert, to look at those images yourself, because it would take just as much time as for any of these hired raters to do it. So instead, you'd say, what if I ask 5 people? What if 3 say cat and 2 say dog? And then how likely is it that the ones who say 3 cat are right? And Lora has given you all these examples to just tell you this is actually not how it works. But fact is, in AI, we've been doing this for decades. And we've been trying basically to flatten all that complexity, because that's the way we design forms, essentially. And that's the way we thought we could summarize all those different answers. I'll maybe ask next a more general question, which is related to, because I see there's some questions coming in, but going back to the aim of this to the theme of this webinar series, which is data-centric AI. What is data-centric AI for you, Lora? What does, if that's not too hard to ask? I think I'm going to ask this question to everyone.
Well, data-centric AI for me is AI processes where studying data, analyzing data, and the impact it can have on model behavior is a first-class citizen in the process, where we don't make assumptions about the data, but we actually measure empirically its impact, especially when it comes to evaluation, where data has much bigger impact on defining whether an evaluation fails or is not, whether it's a good one or not. So data-centric AI for me is AI where we actually gain more. We admit that the data can be a confounding factor for performance of model, and we find ways to identify various aspects of data that show us how it impacts the model behavior in every stage of the model development.
Okay, thank you. And do you think so you said data-centric AI started around 2020, 2021. There was a lot happening in the world at that time. There's still a lot happening in the world right now. But in November 2022, we had ChatGPT all of a sudden, and we all know what happened afterwards. Do you think that data is becoming more or less important in AI since ChatGPT, and why?
I think it has become more important, and I think the existence of responsible AI, the importance of responsible AI since then has increased, which also I think points to the fact that data has become more important. I think we very clearly see in the types of failures that models are performing clear link to the data it's either trained on, fine-tuned, or evaluated on. So I think we, for the first time, actually clearly made the connection between the impact of data. And that's why I'm so excited, because suddenly the type of work that we do is not convincing people we should do it, but we are actually doing it.
And I see a question in the chat as well about how can various professional roles contribute to responsible AI. But for now, just to follow up on that thought. So okay, so those of us passionate and interested in data now have a much bigger platform, perhaps, to apply some of the methods and approaches that we've been working on. To understand that complexity between properties of the data and properties of the models. Do you think anything has changed in methods and practices now that we are dealing with so-called foundational models that are supposed to be applied, are trained pre-trained in a certain way and applied to a range of tasks, compared to, say, some of the examples you had brought up in medicine, where, yes, we were trying to understand that text, that medical text, but we were using slightly different machine learning technologies?
I mean, as we advance, some things become much easier to do, but new problems arise, so for which are problems we've never seen before. So the level of difficulties, I think, is always the same. It's just that it changes its nature. So it has become much more reliable and easy to automatically annotate data with the use of generative models compared to what used to be.
You mean automatically?
Sorry?
You mean automatically annotate?
Yes.
Okay.
So much larger. So get this automatic signal and then study. So this helps a lot to scale also human annotation. In some sense, the amount of tasks that we are performing is also much larger, which gives us much more experience in order to improve those tasks faster and make them more reliable. But however, because there are capabilities of models we were not even imagining a few years ago, we need to define new tasks, and the challenge is to see how much of the learning from the previous types of tasks, when we are talking about completely new capabilities, whether they will apply exactly in the same way. So evaluating a video which exists versus a video that's automatically generated are not exactly the same task. Evaluating the performance of a model that has generated the video is not a straightforward task. So these are things we have never done before. We have never actually evaluated generative output. So some of our tools have become easier because of the power of generative AI, but we are solving new problems that kind of balances off the difficulty at any point in time.
Understood. So I'm going to take a question from the audience now. Taking your examples of images which represent the extremities, so the different types of guitars, which require some imagination, what to call a guitar, what the guitar is. wouldn't it be easier to make results for AI interpretation or generation always marked as biased with a percentage of confidence? So I think so this basically addresses that question of, is there anything objective? So do we have that ground truth, or should we actually just acknowledge?
I mean, if you ask me honestly, I don't think there is a ground truth, because for even simple things, people will disagree because of a different cultural interpretation, experiences, and so on. It's very difficult to find the 2 + 2 is 4 for anything in sort of the real world.
So
we learn a lot from, I think, capturing the distributions of different, allowing ourselves to capture the distributions of different perspectives and viewpoints actually can teach us a lot which topics have smaller spectrum, which have much wider. So we learn how to deal with it. So learn how to deal in the space. We still need to have some kind of sense, where is the most common understanding, or what are the few most common understandings, in order to be able to present information. But knowing that there is a lot more around them will help us present it in a different way than if knowing that there are just a few very distinct opinions.
So this question of presenting, you said presenting, which I think is quite interesting, and I think it's also related to one of the other questions we've received, which I think is asking for more details on how to incorporate that distribution of answers, rather than just the one majority opinion, if that even exists, into the methods that we have to evaluate models. So since rater disagreement is critical in model training, and I would say evaluation as well, any approach or methodology you use to make sure to make sure that the diversity in raters group is considered. So what does that mean in practical terms if, say, 52% of people say yes and 48% of people say no? What does this mean for your evaluation of the model in simple terms?
Well, there is no really simple terms to explain this. It really depends on the task, and it really depends on there are situations. Yeah, there is really not a very easy way of answering this. It will require more drilling down and understanding why. Depending on the reason why, you can take one action. If the reason is different, you can take a different action. However, you can sort of try to proceed. One way of proceeding is sort of identifying the items on which you get a reasonable spread, so a reasonable kind of agreement from a large proportion of your raters, or the users that you're getting. In order to sort of see, because most of the time, yes, I did say in my presentation that there is, in every task there will be disagreement. So there's hardly any, but very much depending on the sensitivity of the task, on the context of the task, this disagreement can be large or small. And most things, at least from responsible AI, most things are relatively safe. Most things are relatively not sensitive. They have sort of innocent kind of information-seeking perspective, let's say. So you can simply choose to basically consider 2 perspectives to be a right answer for one question. Or so really, that's why I'm saying it's very difficult to say, to give a recipe of what to do. If you have, for the examples to which you have high disagreement, you do need to investigate further and see what the reasons for this disagreement is.
Excellent. So there's a lot of interest on this. So I have two more questions about this specifically, and then I'll conclude with some more general ones. So so someone was also asking, if this approach of flattening the diversity in labels has been used to train most AI models, is there a way of addressing the issue in deployed models, so systems we're already using, and mitigating risk of biased outcomes?
Can you say that again?
So
Sorry.
essentially what this says is, yes, we've been disregarding diversity for many years. So we have all sorts of AI systems that were not trained in this responsible way that you were mentioning. How do we mitigate the risks now? Because we've been using AI for many, many years. So they've been taking just the raters majority into account in their data sets. So now what? Do we retrain them? What do we do?
In lots of those, so we are continuously, all the systems that we have right now across the whole industry are continuously improved and retrained. So that's from the learnings that we, the various types of evaluations and experiences of users, identifying failure modes allow us to actually progress and improve. So that's a normal. This is no different for generative AI. This is almost the same process that we used to have for other AI systems, where through the usage, we understand various things that need to be mitigated or changed and improved. There is very little, we cannot predict everything. That's definitely not possible for no case.
So I suppose what we're saying is that once a system is deployed, it's not left to its own devices. It's very important to monitor what is happening and reassess and retrain.
Yes, yes,
exactly.
That's part of the responsible deployment.
So people are also asking, and I'm going to summarize, are there standard tools we should be using to make sure data sets have the required quality of diversity and spectrum of labeling in each domain? So any recommendations? I assume there are some, but do you have any favorite, either from Google or from someone else?
Tools in terms of...
To explore the data sets and see, okay, how diverse is it?
Yeah, so actually in some of my slides in the beginning, I showed the pair tools at Google Research, which are provide a lot of variety of tools to actually drill down through your data. They're data visualization tools, which allow you slicing. So do please check pair at Google. I think at the Data-centric AI Hub, there are a bunch of tools available as well. We have published a number of data sets, which also go along with companion visualization tools. Some of the examples that I showed with images from the adversarial safety task, adversarial nibbler, has a companion tool for exploring the different aspects of the data. So anything, sometimes a simple collab will also do the tool, sort of
so that's a notebook, like a standard data analysis tool, and just looking at statistics and visual exploration. Yeah. Hugging Face has something called data measurement tool. So anything that would allow you to, so I think attention to data is already quite a good starting point. And then in pair, which by the way is pair like couple, not pear like fruit, you will find some ideas of the sort of things to look for as a data detective. Okay.
And a lot of those explorations we also do qualitatively. So it's really important to be able looking at the data, studying specific examples, understanding what happened in every, isolating through kind of statistical tools, isolating a set of examples that's really outliers in some respect to the rest of the data and studying them in order to understand better what happened there.
So people we seem to inspire people to have more questions. We're not going to be able to answer all of them. I'm going to finish with one that is a bit different, that was asked earlier on. I'm going to read it out loud. As an experienced project manager with a business background, in your opinion, are there any career roles or volunteering opportunities in the AI industry that such a role could contribute to in responsible AI or AI alignment? So that's a bit that we're taking a step back from the topic now.
I don't know whether I am qualified in order to discuss various roles or opportunities. I think there are opportunities at every level for engineers, for research scientists, for project managers. As I said, there is the complexity of the problems is very interesting and challenging at the moment. So I think more and more, and with a growing focus on data, there will be more and more opportunities for people at every level to be able to participate and engage.
And if I could just add to that, so those of you who are joining us from the UK, there's various events that not just the Open Data Institute is organizing on data-centric AI, because we are about data, we care about data, but also the Alan Turing Institute. For instance, there was the AI Fringe event that I think was last week, at the same time as the Seoul Summit. We are planning, I think, some activities as well during the London Data Week, which is in July, so not long now. As well as I would recommend people to perhaps join the newsletter of the Responsible AI UK Hub, which is a major initiative of the UK government to build this ecosystem beyond this core set of let's say AI experts, to involve a wider range of roles. Lora, if you're okay with that, I will send you the remaining questions and we will relay the answers to the audience, because I think there's quite a few interesting points that have been raised. But unfortunately, we will have to wrap up. So I've been given a script, which is very good because it's 5 p.m. in the afternoon. But essentially with this, as I was saying at the beginning, this is for us at the ODI an opportunity to widen the conversation. Thank you, Lora, so much on telling us about some very specific ways in which data practices matter right now, in evaluating very advanced AI models for safety and other purposes. I hope people have gotten an idea of just how serious this topic is and how serious this topic is taken in the industry and in the AI community. And I see some sort of slideshows that are being prepared. I'm not going to read this out to you, but just to remind you that this is all part of our wonderful data-centric AI program, and you will receive the slides and you will receive the recording of this webinar via email. But if you want to learn more about what we do in data-centric AI, there is an email newsletter we have set up, which would welcome you to join. And I hope that you will join us again in around a month in July, where we are hoping to bring you an expert who will tell you all about data scraping practices for AI purposes. Thank you so much, and thank you to the team who supported me. Thanks, Lora, again. And I hope to see you all in around a month's time.